Hi, today I just want to go through the maths of special relativity in about 5 minutes or so. And this video is aimed for people who want more of maths oriented introduction to special relativity, because most of the videos which are short are animation or something like that. So this video will give a more mathematical insight, and the other videos which explain relativity mathematically are too long. So this is something in middle, hopefully 5 to 10 minutes. So let's start with special relativity, SR, it's called short form. Maxwell's theory of electromagnetism says light is electromagnetic waves, speed of light is constant in all frames in the medium. So this was what James Maxwell proposed in his theory of electromagnetism. Then Newton's classical physics, speed of light cannot be constant in all frames. So there is a big clash between both of them, as you can see. Speed of light has to be constant in all frames according to electromagnetism, but according to Newton it can't be. Then Newton's classical physics, basically Galilean coordinate transformation laws. As you can see, x prime is equal to x plus ut, relative speed between frames, where u is the relative speed between frames, and t is equal to t prime. So according to Newton, time is constant everywhere in the universe. So that was a big thing, and these were the two laws, basic laws that most of the people use in 11th 12th grade or so. Then so if c is constant, you basically need new coordinate transformation laws. That's it, that's about it actually. And these new laws are called Lorentz transformation laws, and let's start deriving it. So imagine there is a two frames, one s and one s prime, and the coordinates in the two frames are xt and x prime t prime. And the t prime is not equal to t, which we will see in future. That was an assumption in Newton's universe, but we will assume it's not true. Okay, so let's start deriving. So Lorentz transformation in 10 steps. So imagine x prime, which is in s prime frame, is b0 plus b1x plus b2t, and t prime is a0 plus a1t plus a2x, as you can see. Now you can see that t prime is not equal to t, as you can see in equation 2. So time depends on your speed. You often hear space and time got fused into space-time by Einstein's theory. As you can see in equations, x and t depend on each other. Hence, space and time got fused in space-time. So x and t, as you can see, got are related to each other, functions of each other. Now assume the origins coincide of the two coordinate frames, then x equal to t equal to 0 and x prime equal to t prime equal to 0. So if you substitute here, this will be 0, this will be 0, this will be 0. So b0, a0 will be 0. So new equations, b0, a0 will be 0. So you will get these two equations. Now s prime is moving towards right with velocity v with respect to s frame. So when x prime equal to 0, since it's moving towards right, x will be equal to vt in time t, because now we are in s frame, so time t. So x prime is 0, x is vt, and b to t. So using equation a, you get this if you substitute those values. And so b2, when you can cancel t, so you will get b2 equal to minus b1v. Now if you divide equations a and b, you will get x prime upon t prime equal to b1 minus x minus b1 vt because of this. If you substitute b2 equal to b1 minus b1v upon a1t plus a2x. Now s will move towards left with minus v with respect to s prime, since s prime is moving towards right. So s, if according to s prime, s is moving towards left. So when x equal to 0, x prime equal to minus v t prime in time t prime. So when if you substitute x prime is minus v t prime and x equal to 0, so, and this will be equal to 0, so minus v t prime upon t prime equal to minus b1 vt upon a1t. If a1 equal to b1, and when you substitute it here, this a1 will become b1. So this is the next step. You get x prime upon t prime is this, and you just divide by t on both on the numerator and denominator. you get this, as you can see. Now this is a big divergence from Newtonian transformation, since c is constant in all frames. So if x prime upon t prime equal to c, and x upon t will also be equal to c. So speed of light will be constant in both frames. So c equal to b1, if you substitute x upon t as c, that is speed, and x prime upon t prime c, you will get a2 equal to minus a1 v upon c square. If you do this calculation, you just multiply and do some basic high school linear algebra. T prime equal to a1t minus a1 upon c square vx from the equation we had earlier. And if you substitute all those, t prime was equal to a1t plus a2x, so a1 will become a1 and a2 will be minus a1 by c square v. So t prime is basically a1 t minus vx by c square, and x prime was equal to b1x plus b2t, and if you substitute b1 as a1, b2 as minus b1v plus b1 is, but b1 is equal to a1, so minus a1v, you get x prime equal to a1x minus bt. Now s prime is moving towards right with respect to s, so s is moving towards left with respect to s prime. So if you want t and x as functions of t prime x prime, you just have to replace v by minus v in these two equations. So you will get t is a1t plus and x equal to a1x plus. Now this is it, almost we are there. X prime was equal to a1 x minus vt. So if you substitute x as this and t as this in the equation, you get x prime and t prime as functions of each other, and when you expand, these two will cut out, and this it will be x prime equal to a1 square x prime 1 minus v square by c square. This a1 square x1 will come out, so x1 will cancel out. A1 square equal to 1 upon 1 minus v square by c square, which is called gamma. So a1 is basically 1 upon root 1 minus v square by c square, which is gamma, this is a popular term which we will see in all the equations. Now t prime was a1 t minus vx by c square, so t prime equal to 1 upon root 1 minus v square by c square. T minus vx by c square is equal to gamma t minus vx by c square. So t is basically equal to gamma t prime plus vx prime by c square, since you interchange the v sign if you go from t to t prime. Now delta t will be equal to gamma delta t prime if you just do a differentiation, plus v delta x prime by c square, since v and c are constant and gamma is constant. So in the rest frame, that is when particle is at rest, delta x equal to 0. If the frame is moving with the particle, for the particle the coordinate won't change, its coordinate won't change since the frame is moving with itself. So delta x will be 0. So and delta t prime is called proper time in that frame, which is moving with that particle itself. Delta x prime is 0, delta t prime is delta tau, which is called proper time. So delta t equal to gamma delta t. So this is it, this is the formula actually. This is called time dilation, which you saw in various paradoxes and all. So implications is delta t is gamma delta t. Gamma is 1 upon root 1 minus v square by c square. Now if this root 1 minus v square by c square is 0.5, then 1 upon 0.5 is 2. So basically delta t equal to 2 delta t. So if in this delta t is the frame of reference of the particle itself, so if it's moving with some velocity, say 80% of the speed of light, then this gamma will amount to 2, 1 upon gamma will amount to 2. And so when 1 second passes in his frame, when it's moving at 80% of the speed of light, this delta t is outside for a particle which is at rest and observing. So 2 seconds will pass for that particle. So when 1 year passes for this particle, 2 year will pass for this particle. So this is it, this is all you need to know about time dilation. Similar things happen with length. It's called length contraction, and mass also increases as speed increases, but the derivations are similar, and this is all you need to know, like if you can derive the basic transformation rules for special relativity using high school algebra. Thank you.